Alright, start recording it. I thought we'd spend a few minutes seeing how you're doing in the A+ math drill. Why don't you holler out the answer and I'll write it in.
-16 of 1 -70 -7 -1 0 that's going to be sorry.
It's okay. In your mind, are you trying to choose between the numbers like 6, 7, 8, 9?
Yeah.
Okay. Figure out which one of those numbers multiplies by 4 to give you 28.
Oh, 7.
There you go. That's the way you want to check. Almost always anyway.
Yeah. That's going to be -12. -1.
Very good. Not only are you doing good, you're doing them fast. That's really good. All right. Last time we left off solving these simultaneous equations. And let's see, I think we did 1, A, B, and C, and we did 2, and should we just pick up from there, or have you done some of these since then?
I did B2, but I didn't do C2.
Okay, let's start with C then. And you were able to figure out how to do the one you did?
Yeah.
I got a feeling you get this. This is not going to give you any problems. Let me get my desk set up here differently so that I can. All right. So let me write these and label them. And labeling isn't always necessary if it's simple enough, but if it's complicated where you have to multiply both equations first, then the labeling is really quite helpful. Just so you don't get confused, because you end up with sometimes 4 or 6 equations on the page. So how are we going to eliminate a variable? Well, first of all, are we going to use substitution or elimination on this?
Elimination.
Yeah, because it's in standard format. Okay. What can we do to eliminate a variable?
We can multiply the top number by +3.
Okay. Now, this is one case where if I do that, I'm going to have -3y there. But then I'm going to have to subtract the two equations. Then I'm going to have a negative minus a negative. So I'm going to make the suggestion here that fewer mistakes will result if the sooner you turn it into an addition problem, unless it can be immediately subtracted. In other words, if this was a 3x, then my first step is just to subtract the two. But since we have to multiply the top by something, how about we multiply it by a -3? And you'll see then that we still have to deal with these negative numbers, but it makes the subsequent addition going to be easier. Whoops, whoops, whoops. In other words, I can't ignore the negatives. They're going to come in regardless of how I do the problem. But I think this is probably the easiest way to do it, because most people would rather add two equations together than subtract. When you're subtracting two equations, you not only have to do 3 subtractions, but you really got to be careful with the signs. So I think people make fewer mistakes if they're adding equations, not subtracting. And now we can do that.
Yeah.
So what do we have?
Negative 7x equals 28.
Positive or negative?
Negative. The negative 28, yeah.
Yeah, so we still end up with all the negative signs. I'm not sure we've helped anything. But now what's x equal to?
X is equal to negative 4. Or positive 4.
Okay. Now what's y equal to?
Y is equal to 0.
Now remember how we get y. In other words, because we eliminated y doesn't mean it's 0. We were just able to eliminate it by manipulating stuff around. No, to get y, we have to go back into one of the equations and substitute what we have solved for x.
Yeah, so I think we should do it to the first equation. So it'd be 3, and then the 4 takes place of the x minus y equals 3.
Okay.
Well,
So what's the easiest thing to do now to solve for y?
yeah.
What is it? What's our next step? Because it's not 100% obvious on how to do this. There's a couple of ways to do it. You could move the 12. In other words, here's what we have. You can move the 12 over there and then divide both sides by negative 1. That's fairly straightforward. But my personal step of choice is to move the y over there, which immediately turns it positive, and move the 3 to the left, subtracting it, and bang, we got the same answer with same number of steps. I had to do 2 things. The other time we had to do 2 things, but I avoided having to divide by a negative number.
Yeah.
Now, it's not like you have any problems with that, but everybody tends to make more mistakes if they're dividing by negative numbers. 3a. What's the second line I can write? What can I do with 3a?
I'm sorry, the phone's kind of like cutting out.
The photo is? The audio or the...
Yeah, the audio did for a second.
Oh, did it? Oh, okay. I'm on my phone, so I could try Google phone if we're having problems with the audio on my regular phone. But usually it's the other way around. I have problems with the Google phone and not my regular phone.
Yeah, it seems to come back now. I don't know if those, but yeah, now it's getting a lot clearer.
Okay, so just looking at 3 without me rewriting it, what are we going to do?
We're going to multiply one of them by a negative 1 so that it will cancel out one of the 7 lines.
Okay, or notice that this is the perfect one to subtract equations. In other words, if I subtract equation 2 from equation 1, I immediately end up with all positives. I get 7x equals 7. So going through the process of multiplying one of them by -1 merely so that we can add the two probably is not worth it here. In other words, always check to see whether a straight subtraction is going to be easy enough. If it's got a lot of negative numbers, then it makes a subtraction harder. But this one has no negative numbers and doesn't result in any negative numbers. So I would subtract 2 from 1 as my first step. And then you're in like Flint. All right. It's probably not an expression you're even familiar with. There used to be a movie when I was younger that was named In Like Flint. James Coburn played a spy. Okay, what's our first step here?
The b's cancel each other out.
So add the two equations. Remember that you can do two things. You can add them or you can subtract them. And so we add the two equations. Excuse me. I knew I'd made a mistake when 9 didn't divide into 55 evenly. Okay, now what?
Now we bring we rewrite the equations between.
Choose one to plug it into and tell me how to rewrite.
Alright, number 1.
Okay.
And it'd be 2 and put parentheses 6 minus b equals 5. That'd be.
So that's 12 minus b equals 5.
And then move the b to the right side so it's b.
Now you got it. Move the b to the right side. Whenever you move something to another side, it changes its sign. So it becomes a plus b.
And then it'd be 12. I don't know if it's
Well, we gotta move the 5 to the left.
Yeah.
How do we move the 5 to the left?
Oh, I get it.
Okay, so it's 12 minus 5. So
yeah.
It ends up being 7 equals b. Okay. And not challenging us very hard here. Maybe they will in the next couple pages. And these suggestions I'm giving you are not clad in stone. In other words, there's lots of different ways to do these problems.
Yeah.
What would your first step here be?
The first step there would be the a's cancel each other out. Or no, because they're both positive, aren't they?
They're both positive.
So add equation, subtract the equation.
There you go. In other words, if you can get rid of a variable immediately by subtracting, I just go ahead and do it, regardless of how many negative signs I have. But be careful. So we know that this becomes 0. What goes here?
Negative
What?
I think it's negative 1b. Not sure though.
Okay, let's write it like we normally would. We have 1b minus a minus 2. I left off the variables because we don't need them. Whenever you're subtracting stuff that's multiplying variables, it's just the numbers. So what's 1 minus minus 2?
3.
Positive 3.
that positive base.
And
Then it's just that
it's negative 8 minus a 1. Negative 9. In other words, you turn it, here's your subtraction sign. Change the sign of that. Now it's minus 8 plus minus 1 minus 9. All right. Let's go to the next document. And I have a pretty good idea of what we're going to do after we do these simultaneous equations. I think the next most important thing in algebra is factoring and learning how to factor. This must have been the first page showing us how to do it. All right, let's handle some fractions.
All right.
Well, this is an example. Let's cover that up and do that. Hold on. All right. Okay. Now, fractions necessarily are going to make these harder. That's why when we are handling the ones that don't have fractions in them, we go out of our way to not put fractions in there. But, okay, so what's the first step here?
Do you think and switch each other out?
What's that?
I think the and cancel each other out.
If we do what? In other words, always specify whether you're adding or subtracting, because we can do either.
Yeah.
If we add the two equations, the ends cancel. If we subtract the two equations, the m's cancel. But I kind of like canceling the ends myself because I'd rather add than subtract. So what do you get after you add the two equations?
I'm not sure. I'm terrible at fractions.
Okay, we need to practice fractions. In fact, let's stop right there and talk about fractions. Because there's no need for you to be terrible with fractions. If I'm adding 1/4 and 2/4, you have a common denominator. The answer is going to have a 4 down there, and I'm going to add the numerators. Okay? So when I'm adding 1/4 to 1/4, I would get 2/4, which you would then simplify. If I am subtracting, same thing. 1/4 minus 2/4, I get a -1 in the numerator. So it's -1/4, which is the same as minus 1/4. All right. Let's talk about different denominators. If I'm adding let's add 3/4 plus 2/3. Now, adding and subtracting is the hardest thing to do with fractions. It's easy to multiply and divide them. If I'm multiplying two fractions, I multiply the numerators, I multiply the denominators. So that's far easier than adding or subtracting. When you're adding two fractions that have different denominators, you have to find a common denominator. Well, what's the common denominator? between 4 and 3? Okay, let me give you the way to figure it out. There's a pattern that's real easy. Start with the biggest number, the 4, and start increasing it by 4s until you find a number that's divisible by 3. So 8 is not, but 12 is. So 12 is divisible by both 4 and 3. It's the smallest number that's divisible, so it's the lowest common denominator. It goes there, and it goes there. Now, I have to figure out how to get that number. You get that number by dividing your denominator into your common denominator and multiplying that result by the numerator. So what's 4 into 12 times 3?
9.
Yeah. And then check that fraction and make sure that it's the same fraction, that we haven't changed it. Because that's the whole goal here. We can write these fractions in numerous ways, and they're the same. But if I wrote 8 12s, it wouldn't be the same number. So always do that check when you've converted something to a least common denominator. What goes here?
8.
That's the answer.
8 plus 9. That's 17.
That's the answer, 17?
No, 17 over 12.
Okay. Now, multiply those two fractions together.
17 and 12 or, these two, okay. Did you just multiply the top two and then the bottom two?
Yeah, that would give us 6 12ths.
Yeah.
But instead of doing, that's the way you do multiply fractions, but if you can simplify before multiplication, you're dealing with smaller numbers. Okay, and I can do that. I can divide the top by 3 and the bottom by 3, replacing those with 1s. And now I have smaller numbers. I have 2 4ths instead of what I would have had, which was 6 12ths. And what does 2 4ths simplify to?
1/2.
Okay. Now, divide these two fractions. How do you divide fractions?
Yeah.
Flip the denominator and multiply. In other words, it's a lot like turning a subtraction problem into an addition problem. We're going to turn a division problem into a multiplication problem every time. I don't think anybody even knows how to divide fractions by fractions. But we all know how to multiply. In other words, it's going to be 3 4ths, the top, times the reciprocal of the bottom. That's the reciprocal. That's the same problem as dividing by 2/3. Now, 9/8. So both division and multiplication are far easier than addition and subtraction.
Yeah.
All right, hold on. Let me give you one last one as a test. What's the least common denominator going to be? 16 divided. Can 16 be divided by 3?
Yeah.
No.
Oh, never mind then.
It's okay. Remember, there's another little trick. Remember the trick I told you with 9s, where when you multiply 9 by a number, the digits have to add to 9?
Yeah.
Well, a number is divisible by 3 only if the sum of the digits are divisible by 3. And 16, the sum of those digits is 7. And 7's not divisible by 3. So 16 is out. What's next? What's the next one you get when you count up by eights?
24?
No, but you count up by eights. In other words, we examined 8 and then 16. The next one's 24.
Yeah.
Oh, is that what you said, 24?
Yeah.
Oh, I'm sorry, the audio. And is 24 divisible by 3?
Yeah.
Yeah, the numbers add to 6.
Yeah.
But we know that 24 is divisible by 3 because we know our multiplication and division tables. Now, how many 24ths is 1/3 equal to? How many is 1/4 equal to?
Sorry, I'm writing it down.
You don't want to be writing it down, I don't think. Does it make it easier for you to solve it by writing it down? Because what I'm basically doing is giving you a series of division and multiplication questions. In other words, the number of 24ths that 1/4 is 4 divided into 24 times 1. There you go. And then how about this one?
24 divided by 3.
All right. And so now you add up all the numerators. 17 over 24. And that cannot be reduced further. So, all right. Let's see. We only got a couple minutes left here. We'll start here next time. But let's see what else I can hit you with in a couple of minutes. Let's see. With regards to fractions. All right, there's one last problem that some people have problems with, and that's when they divide a fraction by a whole number. What's that equal to?
Would we change the whole number into like a mixed fraction or like a fraction?
Yeah, you can look at it like that. We don't need to change it into a number of thirds, but there's a 1 under it. In other words, 4 is the same as 4 over 1. And now we have a fraction divided by a fraction. So how can this be solved? What do?
We multiply it by the reciprocal, so it's going to be 1 over 4. And then the common denominator is going to be 12.
Okay, it's not a common denominator. We don't need a common denominator when we're multiplying. It's just the multiply the numerators, multiply the denominators. But before we do that, is there any way to simplify it first? Can I do anything with this 2 and this 4?
Oh, yeah. You can... I don't know how you...
It's called dividing the top by 2 and dividing the bottom by 2. Which means is all we've done is multiplied the fraction by 1. And you can always multiply any fraction by the number 1. So if I divide the top by 2, I get 1. If I divide the bottom by 2, I get a 2. Now what's the answer? Yeah, and it's already reduced. In other words, what we would have gotten was 2/12 had we just multiplied across. And then we still got to divide the top by 2 and the bottom by 2 to get it to 1/6. So in a way, there was no additional steps doing that, because I'm going to have to do that at some point in getting to the final answer. Might as well do it here, keep our numbers low. We didn't ever have to deal with 12 the way we did it. That's a bigger number. So, all All right. Ooh, I forgot. I have an 11:30. I can't dilly-dally. Chris, I'll talk to you next time.
All right.
Bye-bye.
Thank you.